Hi everyone, welcome to Intro to Psychology. This week we're talking about how to think critically with psychological science. In the past, there have been debate among scholars about whether psychology as a field is truly a science or not. Hopefully, over the course of this week and throughout the semester, you will come to understand that psychology uses the same methods as other hard sciences. So, what makes psychology a science? It's simply the fact that we use the scientific method to try to answer questions. The scientific method includes observing the world around you, coming up with a research question, coming up with a hypothesis and predictions about what you think the results will look like, testing those predictions, and using your results to make additional predictions. The scientific method puts limits on what types of questions can be answered using true science. We can't usually answer existential questions like, is there life after death, because it cannot be systematically observed. By this, I mean that we can't observe whether there is life after death over and over again in a predictable and replicable way. On the other hand, we can answer questions like, are people happier after they exercise, because we can ask people to exercise and then measure whether they are happy over and over again. In other words, we can repeat our experiment with the same conditions as many times as we want to in order to come up with our results. The three pillars of science are curiosity, skepticism, and humility. True scientists are curious about the world around them and have a healthy sense of skepticism toward claims and beliefs, even their own, and they're humble enough to accept when their hypothesis was not supported by their results and then shift their mindset using the new data they collected. It's also necessary for scientists to be critical thinkers. This can look like many different things, from abstract thinking, trying to think of solutions or observations from multiple perspectives, thinking about the advantages and disadvantages of something even when you feel strongly about it either way, thinking about why you might be wrong about something, thinking about possible counterarguments, and using what you already know and connecting it across subjects or connecting it to new information. Critical thinking takes practice, but it's an invaluable skill for anyone, not just scientists. I encourage you to try this as an exercise. Think of something that you have a really strong opinion on, and then think of possible counterarguments or advantages and disadvantages of your point of view. You might even change your own mind about something. The chapter goes over several different types of psychology. There are several listed here, but generally, if you can think of it, there's a field of psychology dedicated to studying it. I'll briefly go over some of the more popular areas from the list and describe what they study. Cognitive psychology looks at how people think. Research in this area may look at things like how creativity impacts the way you see the world, or how different learning types, for example kinesthetic or auditory, impact the speed with which we memorize information. Social psychology looks at how we relate to other people. Research in this area may look at things like how to get two groups who are political rivals to work together, or the effects of dehumanization on someone's willingness to harm an outgroup member. Industrial organizational psychology looks at psychology in the workplace or in business. Research in this area may look at things like which personality type is best for an accounting job, or how to humanize the medical field and make patients feel more heard by their doctors. Neuropsychology is a relatively new area of psychology because of the advancement in technology. Neuropsychologists look at the physical structure of the brain and what it looks like under different conditions and as it relates to a person's behavior. They may look at things like the area of the brain that's affected when someone is rejected by their peers, for example. Clinical psychology is one of the more popular branches of psychology, and it's broken down into two different areas, counseling and assessments. Counseling is pretty straightforward. These are your mental health therapists. Psychologists who work with assessments and testing are usually on the diagnostic side, however. These are the people who are creating diagnostic materials and criteria so individuals can be diagnosed with certain mental health disorders. They are also usually experts at administering these types of assessments. Lastly, developmental psychology looks at psychology through the lifespan. They may be interested in the mechanisms behind a person's friend-making habits throughout their lifespan or depression rates in the elderly population. This is really just the tip of the iceberg. As I mentioned before, you can come up with a research question on any topic, and it's highly likely that someone else in the field has already thought of it and is working toward an answer. Regardless of the area of psychology, there's almost always a multi-level explanation for someone's behavior, and psychologists call this the biopsychosocial approach. That is, for any behavior or mental process, three things can usually describe why. Biological needs, like the need to survive, psychological needs, like the need to feel loved, and social needs, like the need to have a support system. A good example is friendship. A question here could be, how do people make friends? The answer, as you can probably guess, is threefold at least. Biologically, chemical reactions in our brains can influence whether we like someone or not. Psychologically, one potential explanation is the Benjamin Franklin effect, which is a phenomenon where someone will like you more after you ask them to do you a small favor. Socially, we're more likely to make friends with someone in our in-group. So let's say you're in the band and your friend group mainly hangs out with other band members. They might be unlikely to befriend someone who is on one of the sports teams, but they're probably likely to make friends with other band members based on proximity, shared interest, and in-group status. Now we're going to switch gears a little bit and talk about research. There are two different definitions of research, and students often only know about one of them. The type of research that most students come into college knowing about is when you look up academic articles and put them together to support a claim in a research paper. The other definition of research is the same thing the scientific method is talking about. It occurs when scientists observe the world around them, come up with a research question, create a hypothesis, make predictions, test the predictions by designing an experiment or making systematic observations, and then using those results to make a new hypothesis or prediction. There are three general types of research: observational, experimental, and clinical. And clinical can be either observational or experimental. So technically, I would say there's only two types: observational and experimental. Observational research is done when we can't design an experiment for some reason. A true experiment requires that we randomly assign people to two or more conditions, and sometimes that just isn't possible. For example, if we're looking at smoking behavior and whether it leads to heart failure, we can't put people in a smoking group. In other words, we can't make them start smoking. They're either smokers or non-smokers, and they are in those groups by a self-declaration and not by the researcher. An experiment occurs when we are able to manipulate something and measure a different outcome. For example, let's say we're interested in looking at whether temperature in a room affects memory. We would manipulate the temperature in a room to be either 60 degrees or 80 degrees, and then we would administer a memory test to participants and would then compare their test scores to see if people had better scores on a memory test in a cold room, a hot room, or if temperature didn't affect their memory. In clinical settings, it's possible to do an experiment, but often it's not experimental because you can't put people in certain medical situations. For example, you can't give someone a migraine and then see if a new drug decreases their pain. Something interesting about research and hypothesis testing is that you can't ever prove a hypothesis right. You can only prove a hypothesis wrong. To show you why this is true, I'm going to share with you what psychologists call the white swan hypothesis. Let's say we hypothesize that all swans are white. We go down to the local pond and we examine whether the swans we see are white or not white. All the swans in this pond are white, and therefore the researcher may be tempted to claim that they proved their hypothesis right. Unfortunately, it isn't that simple. There are swans all over the world, and we only counted the swans in our local pond. Even if we sampled every pond in the world, swans can fly, so we would be likely to miss some. The point here is that we can't ever be 100% certain that all swans are white. However, if and when we finally find a black swan, we can prove our hypothesis wrong. All swans are indeed not white. This is a parallel to psychological research. We can test our hypothesis, but even if the evidence supports it, we can never say our hypothesis is proved right because we only did 1 or 2 or even 100 experiments showing that our hypothesis was supported. There's still a chance, however small, that we may find a black swan or a condition in which our hypothesis is not true. The last bit of this lecture is going over some important terms from the chapter and giving you some alternate explanations and descriptions. We're going to start with independent variable and dependent variable. When a researcher is designing their study, they will need to come up with at least one variable that they believe will influence another variable. The variable that they believe will influence an outcome is the independent variable. This is the variable that is manipulated or the variable that is used to group participants. In our earlier example, we thought room temperature might influence scores on a memory test. We can easily manipulate the temperature of a room. Sometimes, remember, we can't manipulate people into a certain condition like smokers or non-smokers. These can still be independent variables, but instead of being manipulated, they're the variable that groups people into separate categories. All you need to remember here is that the independent variable is the variable that we think will influence the outcome. The dependent variable, on the other hand, is that outcome variable. We would measure the score on a memory test, and we think it is influenced by the room temperature, so the score on the memory test is the dependent variable. To explain an experimental and a control group, let's use the temperature and memory test example again. A control group is a group that has not been manipulated in any way. In our example, a 60-degree room is really cold and an 80-degree room is really hot. We could add a control group and make the room around 70 degrees because that's about room temperature. Therefore, the 60 and 80-degree rooms would be considered our experimental groups because we manipulated the conditions they were in by changing the temperature to something other than what they might experience when they normally take a memory test. Confounding variables are a little tricky. A confounding variable is a variable other than the independent or dependent variables that is A, related to the independent variable, and B, influences the dependent variable. For example, let's say we're measuring anxiety levels of smokers versus non-smokers. Smoking status is the independent variable because it's the variable that groups the participants and the one we think might influence anxiety. Anxiety, on the other hand, is the dependent variable since it's the one we're measuring. Our hypothesis is that smoking will increase anxiety. Something we didn't consider, though, is that smokers are more likely than non-smokers to drink coffee, and coffee can increase anxiety. Therefore, coffee is related to the independent variable, smoking, and also influences the dependent variable, anxiety. This makes it a confounding variable. To get around this, you could measure which participants drink coffee and which don't, and then control, using math and statistics, coffee drinking, essentially filtering out the effects of coffee on anxiety for your data. Operational definitions are essentially just asking how you define and measure an abstract concept like happiness. I may operationalize happiness as the number of times someone smiles when they're at a party. More often, researchers use scales and ask people to rate their own perception of their happiness. For example, on a scale from 1, extremely unhappy, to 5, extremely happy, how happy are you right now sitting here listening or reading my lecture? You know what? Don't tell me. Peer review is when a researcher does their empirical research, which is just the second definition of research we were talked about whenever we were talking about the hypothesis testing, and writes up the research report and then asks a knowledgeable peer to review it for them to find mistakes or flaws in their logic. A correlation is when you measure two dependent variables and determine how related they are. For example, let's say one summer I measured the temperature outside and ice cream sales at a local ice cream shop. What I want to know is, when the temperature went up, did ice cream sales go up as well? If they did, that would be a positive correlation. You can have either a positive, negative, or no correlation. A negative correlation would be when the temperature went up, ice cream sales went down. If there's no correlation, that means the temperature and ice cream sales were not related, or you couldn't really make a prediction based on one or the other. Something I want you to remember is that correlation cannot give you a cause and effect explanation for outcomes. In other words, just because the temperature and ice cream sales are related doesn't mean that you can claim that higher temperatures caused ice cream sales to go up. If you remember one thing from this whole lecture, remember that one. The only research design that can give you a cause and effect explanation is a true experiment. Remember when we were talking about the white swan hypothesis, and I said that just because we sampled one local pond, there was a whole world full of swans that had not been observed yet? Generalization is assuming that those results from the local pond are true for the whole world's population of swans. Because it would be impossible to observe every swan in the world, we have to rely on smaller samples from local ponds and hope that our results somewhat mirror the larger population. There are statistical solutions for determining the likelihood that you can generalize your results to an entire population, but you don't have to worry about that for this class. Random assignment is pretty straightforward. You randomly assign participants to two or more conditions. But a random sample is a little trickier to achieve. A random sample means that you recruited participants to participate in your study 100% randomly. That would mean if your population was your entire city, your sample could not be recruited from your university because that would make it a convenient sample. If your population was your entire university, your random sample could not be recruited from your psychology class. For it to be truly random, you would have to recruit one student from every class at the university, and the selection of that student from that class would also have to be random. To do this, you might assign each student in the class a random number and ask a computer to generate numbers randomly from each particular class until you recruited one student from every course. You can probably see how difficult this would be when your population is larger than your university, as it often is in psychology.